Hey you guys. I hope you guys are doing well. Welcome to Algebra. You should have this packet right in front of your face right now. This one. It's white, it's brand new. And you're gonna put your name on it. Make sure your name is on it. My name is Mrs. Brito. So I am going to write Mrs. Brito on it. Okay, so what we're talking about this unit is rational expressions. And you'll see what I mean when you flippity flip to the first page of your packet. What we're gonna do today is look at simplifying expressions, no equal sign. Um, but let's take a look at this one first. 8 over 12. You guys are really good at remembering like how to simplify fractions, I think. So you probably see 8/12 and you think, oh, I can divide both of them by 4. Divided by 4, divided by 4, and you get 2/3. So that's basically the same concept as what we're looking at. But I want you to think about it this way. 8 is the same as, nope, it's not. It's the same as 2 times 4. And 12 is the same as 3 times 4. So what we can do is cancel both the 4's and be left with 2/3. Same concept. We kind of got rid of that factor of 4. We can take that idea and look at polynomials. Right now, we have this fraction. This is the top of your page still. And you'll notice you have x minus 1 on the top, and you also have x minus 1 on the bottom. So just like we could cancel out those 4's, we can cancel out those x minus 1's and be left with x minus 3 over x plus 4. Okay, so we're just canceling out things today. So those were pretty simple. 8 over 12, we know how to work with numbers, and we were already given a nice little simplified expression there. The next piece of this then, what you're going to work on today is simplifying expressions on your own. So we need to start by factoring the numerator, then the denominator. You can eliminate your common factors just like we did before, and then simplify. So the first thing that we're looking at, let's just look at that numerator right now, 3y squared plus 21y. We just spent some time looking at GCF, and I see that I can pull 3y out of my numerator and have y plus 7 left over. And then my denominator is already nice and factored for me. So I'm going to take a look at what's in the numerator and the denominator. Oh, that I can cancel out. Okay, so I have that y plus 7 on the top and the bottom. So my answer, 3y over y minus 2. It might be a little tempting for us to like see that, excuse me, that there's a y on the numerator and a y in the denominator. But because there's subtraction happening with that minus 2, there's nothing else that we can do with that. We can only factor out things that are being multiplied, like that entire y plus 7 term. Okay? The next part of this that we kind of skipped over in Algebra 1 that we do need to talk about in Algebra 2 is when these kinds of things are undefined. Okay? An expression is undefined, and you need to write this down. It's undefined when the original expression, well, the denominator of the original expression. So I guess I can say the original expression's denominator equals 0. Okay, so Any expression is undefined when the denominator equals 0 because I cannot divide by 0. I just can't do it. Yeah, I just can't. So if we take a look up, I almost just use my computer to scroll up at our original expression, my denominator, I'm going to zoom in here. My denominator is, I'm going to use purple, y plus 7 and y minus 2. So that expression is undefined. Oh, you guys, technical difficulties. It's just like I'm there in the room with you, isn't it? Y plus 7 and y minus 2 equals 0, right? That's when it's undefined. So what we're going to do in order to find the answer is take a look at each piece of that equation. Both of the things in parentheses, or if you have something by itself in the denominator, you got to set those equal to 0 and then see. So y minus 7 equals 0. You guys are super professionals at solving equations. So if y equals 7 or y equals 2, my expression is undefined because the denominator is equal to 0. Okay. Take a look at my page, see if you have any questions. Please feel free to write your little question in the margin. I think just more practice is going to help us understand what all of this means. Okay? I'm going to scroll. I'm going to just go over these couple of questions with you before you can practice this on your own. Okay? So this first expression looks like this. This is on page 3. We're going to just look at our numerator first. It looks like we have to factor. X squared plus 4x plus 3 is our first expression. You guys just took a test on this kind of a concept. I had to factor. So I have that number 3. 1 times 3 is 3. So factored, that is x plus 1, x plus 3. That shouldn't be super new. We know how to factor. Then I can take a look at my denominator. That x minus 6 and x squared minus 9. There's nothing I can do with that x minus 6. It's already pretty simplified. There's no exponents or anything. There's no GCF between x and 6. I'm going to just leave it alone. But there's something special about that x squared minus 9. Did it come to your head? Difference of two squares, right? X squared, the square root of x squared is x, and the square root, I'm having a hard time today, square root of 9 is 3. So that x minus 6 stays the same, and then your x squared minus 9 becomes x plus 3, x minus 3. Okay? So all we did so far was simplify. I factored the numerator and I factored my denominator. Now I gotta smush this guy back together. My numerator is x plus 1 times x plus 3. And my denominator is x minus 6 times x plus 3 times x minus 3. So far, all I've done is simplify. I haven't, well, yeah, I factored. So now I have to simplify. I factored. Now I'm simplifying. I'm going to look and see if there's anything in common. It looks like they both have that x plus 3. So I can kind of take those away. My numerator, I'm only left with x plus 1. And my denominator then is x minus 6 and x minus 3. That's my answer. That is the simplified version of this original expression. But I can't forget about what makes that expression undefined. So, and remember I said that it has to do with the original denominator. So I want to think about these 3 terms, I suppose, at where it's undefined. I did cross one out. That's true. One was canceled. But in the original expression, those three things in parentheses are in my denominator. So I need to know where x minus 6 equals 0, where x plus 3 equals 0, and also, do I have room? I don't. Where x minus 3 equals 0. So I just have to solve those. Plus 6. So where x equals 6, where x equals negative 3, and where x equals regular 3 is where it's undefined. So we can say that expression is undefined where x equals 6, negative 3, and 3. I know it was a lot. We are factoring first. We cross out what is the same. And then I have to go back and look at my denominator to see where things are undefined. Okay. Number 2, let's take a look. We have a difference of 2 squares in our denominator. But it's different because that 25 is first. So let's see. I've got 5 plus n and 5 minus n. 25 is a perfect square, n is a perfect square, difference of 2 squares. Okay, nothing's going to cancel, it looks like. So I think I'm done. Check. Okay, moving on. Number 3 looks a little bit crazier, but we're going to take the same approach as we did before. Okay, first I'm going to just write x to the 4th minus 5x to the 3rd minus 14x squared. That's my numerator. I'm going to look at factoring that first. Let's first, always, we look for a GCF, and it looks like they all have an x squared in common. What's left over? X squared minus 5x minus 14. Okay. Now I can factor. I'm looking at negative 14. That adds to a negative 5. So negative 1, 14, negative 14 and 1, negative 2 and 7, negative 7 and 2. I think that's it. It looks like the winning pair is that negative 7 and 2. Negative 7 plus 2 is negative 5. So I'm going to factor that by, oh, I don't have to by grouping because there's no number out front. So that x squared in the front stays the same. And then I have x minus 7 and x plus 2. Because that will get me that, those two numbers, negative 7 and 2, multiply to negative 14, but add to a negative 5. We learned that factoring part last unit and in Algebra 1. And we can't forget that original x squared I had in the beginning. Then I'm going to take a look at my numerator. Nope, that's the denominator. I'm going to take a look at my denominator. 4x to the 3rd plus 24x squared plus 32x. Okay. First, we always look for a GCF. What's the GCF? 4x. Yeah, if you said 4x, you're good. What's left over? X squared plus 6x plus 8. Okay, then we do a little factoring thing. What's times what is 8? That's going to get me a positive. Well, 1 times 8, 8 times 1, 2 times 4. And I think that's my winning pair. So I've got 4x still from before. X plus 2 times x plus 4. Okay. So I took my numerator, factored it out, took my denominator, factored it out. Now I have to smush it all back together. I don't have a lot of room. X squared times x minus 7 times x plus 2 over 4x, x plus 2, x plus 4. give you a second to kind of let that all sink in. So I took my numerator and I factored it. I took my denominator and I factored it. And then I put it back together. So it's the numerator over the denominator. Now I gotta look for anything that can cancel. There's a x plus 2 on the top and an x plus 2 on the bottom. So that can go away. Bye-bye. I also have an x squared over x. If you remember your exponent rules, we can, when we divide them, we subtract. So we can just 2 minus 1 and have an x left over. So that numerator has, that numerator has an x left, along with that x minus 7. The denominator has a 4, but when you see in your pink highlight here, x squared over x just became x in my numerator. This x plus 2 went away, so I've got x plus 4 left over, and that would be my answer because I was able to cancel out everything else. Okay, last little bit before you can practice on your own is to look at where this is undefined. Do you remember that we have to look at the entire original denominator, not the new one that we got because we canceled stuff. We have to look at that original one, this one here in red. I am going to kind of do this up here where I have space. So I've got 4x is one term in my original denominator. Then I've got an x plus 2 in my original denominator and also an x plus 4. I'm going to set all of those equal to 0. This is my original denominator. I also have it here. 4x was the first term. I set that equal to 0. X plus 2 also set equal to 0. And x plus 4 also equal to 0. And then I solve. So x could equal 0. X equals -2. And x equals -4 are all where it's undefined. Undefined. There. I know it looks like a lot, but now is your time to practice. I will post the answer key, but we should not be copying because I want you to practice this on your own. Okay, email me if you have questions. I won't get back to you right away, but I promise I will get back to you. Okay, good luck.